Almost every modern power supply is a switching mode power supply, like this one. But the question is, how do they work? Well, that's what we're going to be taking a look at in this video. Switch mode power supplies consist of two parts. An AC to DC converter, which converts the AC to high voltage DC, and then a DC to DC converter, which converts the high voltage DC to low voltage DC. The reason they do this is because DC to DC converters are far more efficient than AC to DC converters. DC to DC converters like these ones rely on something called an inductor. You can think of an inductor as a bike wheel connected to some pedals. The voltage is the force applied to the pedals, and the current is the RPM of the wheel. If I apply a voltage or a force to the pedals, you can see the wheel begins spinning, but it doesn't instantly get up to speed. It resists it for a short period of time. Now, when I stop applying a force to the pedals, the wheel's momentum keeps the pedals spinning. It's worth noting that the direction of force on the chain changes. When I'm pushing on the pedal, I'm pulling through the bottom part of the chain. However, when the wheel is doing work, it's pulling through the top part of the chain. But how can we use this to change the voltage? To begin with, let's connect our inductor between the positive and negative of the input. Once we do this, the inductor current will begin to rise, and in a perfect world, the current would rise forever. The longer we have it connected, the higher the current. However, in reality, inductors have resistance, but they also have saturation current, where their inductance significantly decreases. If we now connect our inductor over the output, it will try to continue maintaining this current and modulate the voltage to do so. During this stage, the inductor is supplying energy to the circuit, so the electric field shrinks and the current goes down. Obviously, physically moving the inductor is a bit stupid, so what we can use is a switch, both between the positive in the inductor and the output in the inductor. The inclusion of these switches is why they're called switching mode power supplies. But we can actually simplify it even further. You'll note, much like the bike chain, that the direction of voltage over the inductor switches. When it's connected to the input, the positive is of course on the positive input. However, when we disconnect it from the input and connect it to the output, in order to maintain that same current, it will actually flip its polarity and start pulling current from the positive to the negative. A cool thing about the voltage switching direction is we can actually replace one of our switches with a diode and thereby simplify controlling the circuit. There's one more thing we need to consider, and that's isolation. With AC mains lines, you don't need to touch both lines to get a shock. You only need to touch the live wire. This is because a lot of electrical devices connect the neutral line to the earth line, meaning that there is a connection between earth and neutral. Or in other words, there's a voltage difference between live and the earth. And you're touching the earth with your feet, so if you touch the live wire, you act as a path for the electricity to pass through. So in order to stop you getting an electric shock every time you touch an appliance, we need to isolate the output. And in order to do this, we can replace our inductor with a coupled inductor. A coupled inductor is basically two inductors wound around a single core. Now that we hopefully understand buck-boost converters, we can take a look at the circuit for our switching power supply. Probably what you all clicked on the video for. So sorry about taking so long to get there. But you needed to understand this, otherwise the circuit won't make sense. Let's start by taking a look at the AC to DC converter, as it is much more simple. When the power comes into the supply, the first thing it will encounter is a full bridge rectifier, which is a series of diodes arranged in a configuration such that they supply a lumpy DC by flipping the negative side of the sine wave positive. This lumpy DC won't work very well for our DC to DC converter, so we need to smooth it out. In order to do this, we place a large high voltage capacitor in parallel with it. Now, it's worth noting here, these capacitors are extremely dangerous. Here in the civilized world, these capacitors are charged to over 300 volts. However, across the pond in America, they're still charged to around 180 volts, and would kill you if you touch them. So be very careful when disassembling a power supply. Moving on, we have our MOSFET and inductor, which I hope you now know everything about. On the other side of the inductor, we connect our output diode, completing the DC to DC converter. The output from this converter, though, is quite noisy, so we add a number of capacitors to help smooth that out. And that's basically all there is to a switching mode power supply, barring, of course, the control circuitry, which warrants a video of its own. Now, there are some more components which I haven't mentioned yet, so I'll go over them now. On the input, we have a power filter, and this is there to stop the high frequency noise from our switching power supply going back onto the mains. This consists of a X capacitor and a common mode choke. On the output, we'll also find an inductor, and working alongside the capacitors, this acts as a second order low pass filter, further filtering out the noise from our converter. I know some of you are going to be disappointed we didn't go over the controlling of switching mode power supplies in this video, and that's for a good reason. If we take a look at the schematic for one, you can see it is far more complicated, and really we don't have time in one video. So I will be making a follow-up video on that at some point in the future, but I've got a lot on my plate, so that might be a little while. Congratulations, you made it to the end of the video. Let me know what you'd like to see in the next video. And if you enjoyed it, please subscribe.